how do you make a can that's also a bottle? What's the secret to making a lighter light up? Can the way a guitar is made show up in the sound when it's played? And how do they get peanut butter into all of this chocolate? Find out next on Factory Made. Take a close look at this bottle, because it's not what it seems. These so-called bottle cans combine the convenience of a resealable, reusable bottle with the cooling power of an aluminum can to give the drink inside the best of both a bottle and a can. What sounds like someone hitting the jackpot is actually just the ka-ching of the flat metal discs that will get stretched out into the bottle cans. The discs are made almost entirely of virgin aluminum, a kind of aluminum ore that hasn't been mixed with anything else, so it's totally pure. It's also extremely strong, lightweight, and flexible, so it can be shaped or stretched into just about anything. A machine called an impact extrusion press does the stretching. By punching each disc with a cylindrical ram that hits it with 450 tons of pressure. The impact forces the aluminum to stretch itself up and around the cylinder to form a tall can. The machine can't work at a slower speed, so here's a look at it in slow motion. So you can see how the powerful impact forces the aluminum to wrap and stretch around the ram. At real speed, it takes just a fraction of a second for the disc to go from a 1/4 inch thick to a cylinder that's about 7.5 inches tall and about 7 times lighter than a glass bottle of the same size. The press uses such massive force, the tops of the cylinders come out of the press with a jagged edge. So a machine with a carbon knife trims an inch off the top. And to help prevent spills, another machine punches a dome into the bottom of the can. The dome will help stabilize the can wherever you put it down. Then, a rotating steel brush buffs the bottle cans so they can be printed with logos and other artwork. The brush roughs up the aluminum surface so the ink will stick. A washer rinses the bottle cans so they're clean for the ink. And the bottle cans queue up by the thousands in a machine called the accumulator. This dizzying dance is simply to stall the cans, so they don't come too fast and back up the production line. So this wall of cans is really just a holding pattern until the next machine is ready. When the line is clear, the insides of the cans are painted first with an epoxy liner that's both tasteless and non-toxic. The liner is needed so the aluminum won't leach into whatever you're drinking out of the can. The protective liner bakes on inside an oven at 446 degrees. And then the outsides of the cans are decorated with colorful logos that are printed directly onto the aluminum with rotating drums that are coated in ink. First, the bottle cans get a base coat of gray ink that sticks to metal like most ink sticks to paper. Then, the cans travel through a lithograph machine that prints the cans with a 6-color design, one color at a time. We open the back of the machine so you can see how each of the rotating drums adds its own color. This plate adds the green. At full speed, It takes this machine just a half a second to print the full 6-color design. But the printed bottle cans still look more like cans than bottles. So a press crimps the distinctive necks into the aluminum that makes the bottles easier to grip while on the go. As the bottles rotate inside the machine, 15 different steel dies push in the aluminum 1/1000th of an inch at a time to gradually form the bottlenecks. If they tried to do this with a single die, the force needed to shape the neck would crush the aluminum. The very last die adds the separate plastic piece with grooves to the neck so the cap can be resealed. The finished bottles get a good cleaning. And just an hour after work started on the discs, the bottle cans ship out to bottling plants to be filled with your favorite soda, energy drink, or even a nice cold beer. Next, what goes into a lighter to make it light? And why it takes a high-tech laser to make an old-fashioned acoustic guitar. Since the dawn of time, man has wanted to make fire. And hundreds of thousands of years after the first flicker of a fire stick, a flick of a wheel is all it takes to light up a lighter like this. It's an instant flame in the palm of your hand. But only if the fire makers inside the lighter work together to make a spark. If you're going to have an instant flame, you need a way to carry it. So these lighters start out as huge brass coils that uncoil into a hydraulic press where a die pumps up and down inside the machine to stamp out the tops and bottoms of the lighter cases. The cases come together on a rotating table where workers add the tiny hinge that flips the top of the lighter to open and close the lid. One worker loads the hinges into the machine, and another positions the case bottoms and then the tops. Then, a robotic spot welder takes over to fuse the hinge to the case. It looks like the welder hits the case with just a gentle tap, but it actually sends 480 volts of electricity through the contact point to bond the case to the hinge. The weld sets instantly, and a robotic arm knocks the cases out of the machine. Then, the brass cases are dipped into a series of blue-green baths that are more about toughening up the cases than they are about cleaning them. The greenish bath contains trace amounts of nickel that adheres to the cases to protect the softer brass from wear and tear. Then, it's into a bluish solution that's mixed with trace amounts of chrome to make the surface of the cases shinier and easier to clean. Think of it like the thin glaze on a donut. Just enough coverage on the cases to prevent tarnish and rust. While the cases dry, another hydraulic press stamps out the steel inserts that fit inside the lighter cases like a little fireplace to hold all the fire-making tools that actually make the flame. First, there's the wheel that you flick with your thumb. It grinds against a flintstone that's tucked into the insert to make a spark. The spark ignites a cotton wick that pokes up out of the insert into the little chimney-like area on top, and that makes the flame. Putting it all together starts with the tiny wheels that generate the friction that lights the flame. These wheels are made of super strong carbon steel, so they should last for 20 years or more. A robotic arm makes sure the teeth on the wheel are facing the right direction so they can gain traction on the flintstone to make the sparks. The machine grabs an insert and drops it upside down over one of the wheels, so the wheel can be riveted into place. Then the machine adds the wick. It's made from a cotton-like fiber that's laced with copper to make it strong. And it's actually non-flammable at this point. The wick doesn't become flammable until the body of the insert is filled with lighter fluid, which is done after the lighter leaves the factory.